Students, this is Cambridge IGCSE Physics Paper 6, Alternative Practical, October, November 2023. Let's start with question number 1. This is a question 1 in which a student investigates the period of a pendulum. The figure shows the setup. The setup is there is a ball with a support, and the student adjusts the length of the pendulum until the distance being measured from the bottom to the support of the center to the bob is 90 centimeters. He displaces the bob slightly and releases so that it swings. He measures and records in the table 1.1 and the time t for the complete 10 oscillations. Now calculate and record in the table the period t of the pendulum. The period is the time for one complete oscillation. Now calculate a value for t square and record of t. Now first we have to calculate the t. This is the time period, and then we are going to take the square of the time. So at first, we should know that what is the period for any pendulum. So the period t is actually t is equals to dividing the time with the number of oscillations. This is how we calculate number of oscillations. Now, when we are going to calculate this t, since we know that there are 10 oscillations, 10 complete oscillations, so we will divide this 19.1. To calculate this t, it's 19.1 divided by 10. The number of oscillations are 10, so it's 1.9. So here the value will be 1.91. To take the square of 1.91, it's actually, when we take the square of 1.91, it is actually 3.6481. And when we talk about the three significant figure, it is 3.65. Now, after rounding it, this is 3.65, and since we all have to take the values, and every single time we have to take the values of in three significant figures, so this value will be 3.65. Similarly, when we take for the 45 centimeter, the time is 13.5. So we are going to divide this 13.5 same manner. This t is 13.5 divided by the number of oscillations, which is 10, so it's 1.75. So here it was 1.91. Here it was 3.65. Okay, we have 1.35, and taking the square and the value of 1.35 square is equal to 1.8225, but taking the value to three significant figures, it's 1.8, so the value is 1.8. Now they say that the student repeat the procedure using the 45, so we have found the value. Now calculate the period of the pendulum, so we have completed this table. In this case, we have to now complete the column headings. So if we talk about the column headings are T is for seconds. So we are going to write T for seconds, and T square is for second square. So this is how we have completed the column headings. Now, moving on to the next part of this question, the D part. Okay. Now they're asking us explain why timing 10 oscillations give more accurate result for the period T than timing 1 oscillation. So the answer would be, if we say that can write here that the timing 10 oscillation is to minimize the effect of random errors. So we can say that to minimize the effect of random errors. And of course, it improves the accuracy in the distance measurement. So when we talk about why taking 10 oscillations to minimize the effect of random errors in timing. measurements. Basically, we are talking about timing. So this is how. Now they say describe one technique that you use to improve the accuracy when measuring the distance d. You may draw a diagram to help your description. So we are going to write down here. The technique to improve accuracy is when measuring the distance, we can use a set square. So we can use a set square to ensure that the ruler is held perpendicular to the bench. To ensure that the ruler is held perpendicular to the bench. Now, basically, why we are doing it? To minimize, the reason behind it is to minimize the parallax error. So the reason is to minimize parallax error. Parallax error and ensures that the distance is measured accurately. So this is all about this question. Now, moving on to the next part F. When we say that describe one technique that you use to improve the accuracy when measuring the time period for the 10 oscillations. Now, here we have improving accuracy in time measurement is like time for 10 oscillation is measured multiple times. Multiple time and the average is calculated. So this reduces the effect of again random. So again, we can say that if we are taking the time for 10 oscillations measured in multiple times, then the average is calculated. This would be the best technique. So let's write down here the technique. The technique would be the time is measured multiple times, taking it again and again. Multiple times we are taking this time and taking the average, which reduces the effect of again random errors to reduce the effect of random errors. Now the pendulum is 40 centimeters above the bench. We know that to estimate the distance between the bottom of the pendulum support and the floor. Now we know that basically the distance between the bottom of the pendulum support and the floor is estimated. So the pendulum is 40 centimeters above the bench and a typical bench height is around 80 centimeters. So we may calculate the distance. We can write the distance between the bottom and the pendulum support and the floor is equals to 40 plus 80, which is equals to 120 centimeter. With the correct unit, it's also written 120 centimeter. Now, a student plans to plot a graph of t square against d. Suggest suitable values of d that the student can use to obtain the measurements that are sufficient for this task. Now, the suitable values would be like if we take sufficient for this task is suggested, so the values should be spaced out, covering a range of values that are not too small, not too large. So I would suggest that the values could be like 10, 20, 30, 40, 50, and 60 centimeters. These may be these are the sufficient values. They are not very small values, not very large values. So this will cover all the necessary values. Okay. Now, moving on to the next question. Question number 2. A student investigates the cooling of the water in the metal container. The student uses the thermometer to measure the temperature, theta R, which is shown as 23 degrees centigrade, which shows clearly on the figure below. Now, this is the temperature which shows here, it's 23, and the reading is theta R. Now, figure shows the apparatus for this investigation. Now, the student pours 200 centimeter cube of hot water into the metal container. In this metal container, she's going to pour 200 centimeter cube. This is the volume. She places the thermometer in the hot water in the container and she got the temperature at time T is equals to 0. And then she immediately starts a stopwatch. She records the temperature in the table at 30 seconds interval and until she has 7 sets of readings. Now she has taken all the readings in the table. You can see the table is here in front of you. Now they say that complete the column headings. So the column headings are very simple column headings. The time is in seconds and the temperature is in degrees centigrade. So this is the simple, like all these are the values of the time and the values of the temperature. Now in the next part, since we have to make a graph, so let me write down the values here for reference, for time and for temperature. 0, 0 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. And the values of the temperature are 92, 86, 82, 79, 77, 75, and 74. Now let's move on to the next page to see how can we make that graph. Now we have to complete the graph. Now they say that you do not need to plot a graph of the temperature theta y-axis against the time t-axis. So on x-axis, we are going to take this x-axis, the time will be taken. On y-axis, the temperature will be taken, and label your axis appropriately. You do not need to start the y-axis at 0. Draw the best fit curve. Let's start it with the time x-axis. So for that, we are going to do this. Let me take the axis first. And a little bit beyond that, so we can just easily avoid. And here it would be that. Here it would be that. Now let's take the time on x-axis. So we can see it's 0, 0 0.5. So here we have now the points will be written as 0. So this is 0. Because this is 0, then 0 0.5. So 1, 2, 3, 4, 5. At this point 5. By taking this 0 0.5, then 6, 7, 8, 9, 10. So here it's 1. And 1, 2, 3, 4, 5. It's 1.5. Or maybe we can just take the values a little bigger. So it would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 0 0.5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 1. And almost this would be 1.5. Let's see if we are able to do that. I think this would be more appropriate. This would be 1.5. It would be 2. Then it would be 2.5. 2.5. Then would be 3. This would be more appropriately, more clearly, it would be like this would be 0 0.5. and this would be 1. This would be 1.5, and this would be 2, and this would be 2.5, and this would be 3. So these are the values of the time, and with the temperature. So see the temperature, the temperature is like the minimum temperature. This is that do not take the temperature. Particularly, they mentioned one thing, that if we see that, we do not need to start the y-axis at 0. It's not necessary to start the y-axis at 0. So we are going to start the y-axis at like, maybe that is going to be, we can take it like here we can start with because the values are from 70 till 90. So we start it with 10. Take the values as 10. 10. Here the value might be 1, 2, here it's 7, 10, then we take it to 20, and if we take it to 30, 40, 50 would not be possible for us. So maybe we can use the values as like where the values can be 20. It could be 20, 40, 60, 80, and here the value can be 100. Right. Okay. Now let's start plotting the values. So at 0, the value is 92. So this would be almost like, if this is 90, it would be, this is the point. Then at 0.5, it's 86. So this would be, might be, this is the value, like 0.5, the value is 86. At 1.0, it's 82. So it's 1, and the value is 2. At 1.5, the value is 79. So it's almost if this is 70 and this is 79. So this will be the value at 1.5. And at 2.0, the value is 77. So yeah, this will be like here. And then at 2.5, the value is 75. So it's again, here is like, this is the point. And then at 3.0, the value is 74. So it's almost like, you know. So that's almost the best curve. So let me just join the values to make a graph. And we are going to join all the nodes to make the best curve. This is how we have to make the curve. Now that the graph shows that these are the values. Moving on to the next part. Okay, the student states that the average rate of cooling of the water decreases as the temperature of the water approaches room temperature. Now state whether your graph line supports this suggestion. Explain your answer by reference to the shape of the graph. So let's look at the graph once more clearly, and then moving on to the next question. So this is the graph. If you see the graph, this is the graph. Now basically the graph shows that the average rate of cooling of the water decreases. This is the average rate of the rate of cooling decreases as the temperature of the water approaches the room temperature. So the graph of the curve is steep in the start and becomes less steep as the time increases. If you see that the time is increases, it is less steep. It means that the rate of the cooling is higher when the temperature difference between water and the room temperature is greater. Rate of cooling is higher because rate of cooling means that the water is cooled at a at a larger rate, at a greater rate, when the difference between water and room temperature is greater. Between water and room temperature, that is greater, so we can see it. So we see that it reduces as the water cools. So let's write it down. The technique, we are going to write it here. They say that the student states that the average rate of cooling of the water decreases as the temperature of the water approaches room temperature. State whether your graph line supports this suggestion. Yes. So we are going to explain our answer with the reference to the shape of the graph line. So we will be writing that the graph shows that the average rate of cooling. Let me just write down the statement here. So the statement shows that the graph shows that the rate of cooling of water decreases. Rate cooling water decreases as the temperature approaches room temperature. Room temperature. Now, when we talk about the curve of the graph, yes, it supports that the curve of the graph, as we have seen, it was the best fit curve we have seen. So the curve of the graph is steep in the beginning, in the start, and becomes less steep as the time increases. As the time increases. Now, so this shows that the rate of cooling is higher. Now, we can write one thing here. We can say that it's basically they are talking about that the rate of cooling is higher when the temperature difference between them is greater between water and room temperature. Room temperature is greater and it reduces as the water cools down. Cools down. So this is the explanation of this part. Now, moving on to the next part, as they say, explain why. Now, this is the question that explains why it is a good practice to read the thermometer scale at the right angles. Now, basically, when it is always suggested that the reading should always be taken at the right angles to minimize the parallax error. So the answer for this question is to minimize the parallax error. Okay. Now, they say that draw a measuring cylinder containing water, or to this one, containing water, and on your diagram show that the line of sight you use and obtain an accurate angle of the volume of the water. Okay. Now we are going to draw a cylinder. Draw a cylinder containing water. So this is the cylinder. Now, what we have to do, we have to take it is suggested to draw a measuring cylinder. We have taken a measuring cylinder, and on the diagram, we have to show that the line of sight we use to obtain an accurate angle with the volume of the water. Okay. So basically, what is happening here? Like, we see that the measuring cylinder should be drawn like that, and the line of sight should be indicated with a horizontal line. So when we are talking about the line of sight, when we say that, it should be horizontal. This is the line of sight, and horizontal at the level of meniscus. Now this is the level of meniscus. And we can say that this is the curve, basically, it's the curved surface of the water. And to ensure that the accurate reading of the volume is taken. So this is how we have to take the water level to obtain the accurate reading of the volume of the water. Okay, now moving on to the next question. Here we have this one. This is the student investigates the image produced by the lens, and the figure shows the setup. This is the illuminated object. There is a hole, the lens is placed here, the screen is there, and the adjustment of the lens is made so that the distance between the lens and the illuminated object and the object which is placed at this point is u, and this is v. From the lens and the screen, the distance in between them is v. So on the figure 3.2, measure the height HO of the illuminated object. Like if we are going to plot it here, it's like that. It's HO, and the value of HO is roughly 1.6 centimeters. Now, what we have to do here, the student then places the lens at distance u is 25 from the illuminated object, and he moves the screen until a clear focused image is formed in the screen. He measures the distance v between the center of the lens and the screen. Now describe the two techniques that we use to obtain clear focused image. Now there are two techniques. The two techniques are here. Let's talk about the two techniques that move the screen slowly, and back and forth, and the next is darkened room. There should be darkened room and bright object. These are the techniques we can use to take a clear and focused image. Okay, next we have calculate the focal length of the lens using the equation. This equation is already given. Give your answer in three significant figures. Now, it's very important to take the answer always in three significant figures and include the unit as well. They haven't given the unit. Now, what we have to do, we know that the value of u is 25 in this case, and the value of v they have taken is 41.2. Now, they are going to take u into v over u plus v. So it's 25 into 41.2 over 25 plus 41. So the answer that we have gotten is 15.559. And by rounding it to the three significant figure, the value is 15.6 centimeter. The unit is centimeter, and the value is still three significant. Now they say that the object is brighter than the image. Complete the sentences to describe two other ways in which the image seen on the screen is different from the object. So how the image is different from the object? The first thing is that the object is not upside down, but the image is upside down. Or you can say it's inverted image. And the second thing is that the image is magnified. It's not the original lens. It's the larger image or the magnified image. So these are the 2 points that we use to say that the image is always different from the actual object. Okay. Now here we have the student completes the step by using the distance u is 30 and v is 29. So again, putting the values u is 30 and v is 29.8 in the formula. So it will be 30, 29.8 over 30 plus 29.8. So the answer we get is 14.9498. 98, and rounding it to the three significant figure, we get 14.9 centimeters. Okay, state and explain whether your results for the focal length are equal with the limits of experimental accuracy. Yes. If we see that the result is 14.9 centimeter, as I already told you that the focal length should always be, if your values are from 14 till 16 centimeter, the answer is always within the limits of accuracy. And we can say that yes, because the statement matches with the answer. So yes, the focal length are within the limits of the experimental accuracy. And we say that the justification matches the statement with reference to the values being written 10%. So we can write here that justification matches the statement with reference to the values. If we see the reference of values are exactly the same within 10% of each other. So they are basically almost the same. This is how we have done this. Now moving on to the next question. Now this is the question. A student investigates the current required to melt the fuse wires. And here the experiment is taken. Now we see that the following equipment is also available. Fuse wires with selection of different diameters and metals all with the same length. And then meter ruler, ammeter, variable resistor. Prepare an experiment to investigate how one factor affects the current required to melt a fuse wire. We do not need to write about safety precautions. In your plan, state the variable that you choose to investigate. So basically, this is the thing that we have to state the variable that you choose to investigate, complete the circuit diagram. We're going to complete the circuit diagram. So first, we are going to talk about the variable that we choose to investigate. So the variable is the diameter of the fuse wire is the variable chosen to investigate. So here we are writing the answer for this first one is diameter of fuse wire. This is the answer for the first one. Okay. The diameter of the fuse wire, this is the variable that we are going to investigate. Okay. Next, we have completing the circuit diagram. So when we move on to the circuit diagram, and we see this is the circuit diagram. It's completed by adding an ammeter. Ammeter in series with the fuse wire. Now here we are going to draw the ammeter. So here the ammeter is drawn. The ammeter is drawn in series with the fuse wire and a variable resistor in series with the rest of the circuit. So here the variable resistor is the variable resistor. The power supply is represented by a circle with a positive and negative terminal. So here the positive and the negative terminal should be there. So here it should be positive and negative. And this is how with a positive and negative terminal. Next, we are moving on to this one. Okay. Now explain briefly how to do the investigation. Now, how will we do this investigation? The investigation process says that a fuse wire with a specific diameter is selected and placed in the circuit. So we are going to talk about this in detail here. That the first step is to take the fuse wire and place it in the circuit. Take fuse wire and place it in the circuit. Step number 2, the variable resistor is adjusted to the maximum resistance setting. Variable resistor is adjusted to its maximum. It is adjusted to maximum resistance settings. This is point number 1. Then we are talking about point 2. here the point number 3, that the power supply is switched on. Power supply switched on. Switched on. Point number 4 is to variable resistor is gradually decreased. Variable resistance resistor gradually decreased or reduced, increasing the current. So increasing current. Next is the ammeter reading is continuously monitored. Ammeter reading, monitoring. Then we are going to say that the current value is recorded when the fuse wire melt. At the time, the current value is recorded when fuse wire melts. And then the power supply switched off. The power supply is switched off. And then the procedure is repeated with different wires of different diameters, ensuring each wire is made of the same metal and length. Now, this is also very important that this procedure is applied. The procedure is repeated with same metal but different diameters of wire. To check. Now the next thing is state a key variable to keep constant. So the key variable would be type of metal and the length of the fuse wire. So here we are going to say the constant is the length of the wire and the metal. Next, draw a table with column headings to display the readings. You're not required to enter any reading, just a table with the column headings. So the column headings, the table would be, it's like and the table would be, now making the table. It's like fuse wire diameter. The first is fuse wire diameter. And the second should be here we have melting current. And the melting current, and the units are like the fuse wire diameter should be in millimeter and the melting current in ampere. We're not supposed to put anything in the table. Now, explain how to use your results to reach a conclusion. Okay. Now, after this, we are talking about the conclusion. So the conclusion is that the melting current are compared for the different fields. The melting current are compared, values are compared for basically different fuse wire diameters. Fuse wire diameters, and the graph of melting current can be plotted. Graph can be plotted, and the relationship between them can be analyzed The relationship can be analyzed, and the graph a conclusion can be made that how the diameter of the fuse wire affect the current required to melt. So this is all about this. I hope you have understood all about this ATP. Stay tuned for more videos.